Assalamu alaikum. My name is Mohammad Shajibul Islam Sheikh. Now I am talking about the UDMA course, which is NLP for beginners using NLTK. So this is actually the overview of this course. In the few months ago, I uh, have done these courses, and now I represent an overview of this course. So first of all, but we need to know about the corpus. Corpus is basically the whole of a text of the training, which we are using for training in the machine. It is very straightforward that the corpora means the text of the training and testing purposes are using for training and testing purposes. And so first of all, in NLTK library we are importing Gutenberg. So Gutenberg is a pre-bank which has more than 2 million 2 million words are belongs in here. So we files file ideas, we are calling this function, then we are seeing this type of text are belonging in Gutenberg. So from there we have extract just one text, which is Bible. So now we are using Gutenberg.raw for extracting the Bible, and we are putting this in the R Bible. It is a randomly named. So now we are seeing this. The King James Bible, and it is most the hundred uh, it is the hundred words of text. So now we are moving, it is a sentence, so we are now moving into the word. So that's why we are calling Gutenberg.word. So that's and then if we are seeing just 10 words, then it is generate this in this line. And then we are seeing at this as 3. So here is the this kind of individual words. And then if we are using the brown corpus, then import brown and brown categories. So then we have got some adventures, fictions, government, hobbies, humor, and many more things. Then if we are categorize humor, then we get this is series. And then what is actually in the humor, what words belongs in humor, then it was give that it was among these that hanky, just like that. So then brown sense sentence and in sentence the category is humor. So that's why it is generating this line. So that is the that is the idea of the Gutenberg and Brown corpus for corpus that they have talked in their lecture. So now we are moving to the second part, which is frequency distribution. So for frequency distribution we need to import two kind of fragment, that is conditional frequency distribution and frequency distribution. If we write a string, I saw Sushi sitting in a shoe shine shop. Where she sits she shines, and where shines, she sits. Now if we split this, then it is divided into a individual chunk of words that we are seeing in here. And then if we are calculating the frequency distribution, now which words are word, actually it is the word count, which words are the number of words of the number of words in these sentences. So that's why we are calling frequency 1. So L, so that's why we get that she gets 4, I gets 1. That means in these sentences, after splitting this into a splitting this that the total in this line, she is belonging 4 times, I is belonging 1 times, so is belonging 1 times, just and last like that. So that's why the most common, if we try to find out the most common part, then we got that she and I, which is mostly common in these sentences. Then if we are call brown, then import brown, then it is a corpus. So then if we categorize words, if we use categorize humor, then the humor size is 21,695. Then if we are try to find out the frequency distribution, then and the topmost word, then we got that the comma is belonging 1331. Then d is produces 930, and sort of the other words which are belonging in the humor side. This is the actual number, and it is sorted by the ascending descending order. Then return to the return a list of all samples that occurs once. If we figure it out which words are occurring just 1 times in the whole corpus, then we are calling hapex, that it gives us that hanky, fencing, marriages, this type of word are using only 1 time in this entire compass. Then if we figure it out, what is the max symbol are using in this entire corpus, then it gives that comma is mostly used in this entire corpus. Then if we try to find out the frequency of the word D, then we get that it is 0.04287, and we are get the in the entire compass, that is 930 times. Da is using 930 times in the entire corpus. If we are divided it, divide 930 divided the whole number, whole amount of number which we are generating in here, 21,695, then we get the frequencies, that is 0.0428, which is the same of the frequency of the word they. That is actually mathematical logic. So then we are moving to the conditional frequency distribution. Here we are generating the three part manually. Cat 1 good, cat 2 bad, cat 1 good. So now we are trying to if we are moving this corpus into the conditional frequency distribution, then if we figure it out cat 2's behavior, then it generate that bad, and 1 times cat 2 is bad, which is just occurring 1 times in this corpus. And then cat 1 good is probably the happening 2 times in this corpus. Yes, first good, and yeah, 2 times. Then if we are generating the whole number which is occurring in the corpus. We are with different genres: news, regions, hobbies, science fictions, romance, and humor. And modals: can, could, may, might, must, will. So then we got that news, which is close to can, is 93 times, code is 86 times, may is 66 times, regions, which is close to can, is 82 times, and hobbies, which is close to can, that is 268 times. This is the whole an overview idea of the corpus. Then the names and the last letter from NLTK, we are import NLTK corpus import names. Then male, we are using for male text and female text. Then we got the frequency value of n is 478, e is 468, y is 332. This is the frequency distribution. So if we are figure it out for male and female individual, then we see that the female ratio is higher for this individual type of, for this particular corpus. And this is the actually figure of the male and female distribution. Yeah, this is the whole idea of the frequency distribution. Now it's the lemmatization. So actually lemmatization is the dictionary word about dictionary word of the main of the different type of word. Let's say am, is, are, that is the are actually the be verb. So if lemmatization can just print b, use b for this entire am, is, are, was, were. For this be verb, lemmatization only use b. So here we are using NLTK corpus import wordnet as wn. So if we calling synset and for spoke, then we are now getting sort of this. And then we are using the talk v dot v dot 01 as synset. Then and if we are seeing this in this particular site, they have we often talk business, action talk louder than words. So now if we are trying to figure it out that to the words, then we are using separate by semicolon, colon. Then this are separated into individual word, which are the actually use here using spoke. Sometimes speak, spoke, spoken by or speaking. All of this type of word, it only use spoke. So then it is same to talking, talked. For all of this kind of chunk, it only use talk. And all of these are calculating by this idea. So wordnet, then we are import wordnet lemmatization. Wordnet lemmatization is spoken, is given, is spoken, verb is speak, and worst adjective bad. So this is the this is mainly the dictionary word types. So then the stemming is a sort of lemmatization, but there have some other properties. So in here we are calling NLTK.steam import porter steamer. So if we are seeing this steam walking, it's goes to walk, calculate. And if we are maximum, then it introduce maxim. Actually steaming is the suffix or prefix reducing from the word. Then actually it is happening in here intelligently. then it is take it intellige, so multiply is take multiply. And then if we are import regex system, so in regex system we are actually it is the regular expression. So if we are seeing this in control level, then it only goes take control. And then the final one is tokenization is actually the word in natural language processing. The word is actually called by token, actually called token. So from NLTK tokenization, import word tokenize, sentence tokenize. First of all we get the sentence, then we then we transfer the sentence into the particular word. So that's why we are introducing word tokenization and sentence tokenization in this particular task. And import Gutenberg to see the book are available. Then we are see that these books are available in Gutenberg. So if we are now previously we are using Bible, and now we are using Austin Ima text. So in Austin Ima text we are sort this like 50 to 477. So then it generates this line which is belongs to the 50 to 40 477. Now if we this is the if you use sentence tokenization, then actually here two lines are belongs. So that's why a len of s is 2. And if the first sentence we are figure it out which is the first sentence, then we use s 0, then the first line produces. And if we set 1, then it produces the second sentences. So then we you want to split it by dot, then it gives like that. Here the final last is last here is the dot, but in here no dot exists. So then if we are splitting this type of different sentences, now if we are moving to these sentences into the particular word, then we are using word tokenizer for s40. Then x4 is 16 years had Miss Taylor been in the Mr. Woodhouse family. So this line it can generate for the particular word are separate in here. And that is the actually work through for tokenization. So that is the actually that is the whole idea of this courses, as it is a very beginning course. So this type of chunk is talked in these courses. So thank you for joining.